Our today's topic of discussion is from the geography part of climatology, that is insolation. Insolation refers to the incoming solar radiation to the earth, and it is expressed in watt per meter square and measured in energy per unit area. Insolation varies spatially and temporally. Spatially means region wise, and temporally associated with the time, that is for temporary period. There are majorly 6 factors which affect the solar insolation, and these are angle of incidence, duration of day, elliptical orbit of earth, atmospheric processes and cloud cover, aspect of slope, and the sunspot cycle. These 6 major factors which affect the solar insolation. So let us discuss the first part, that is factors affecting solar insolation due to angle of incidence. So the basic part which we have to remember is that in physics we consider the angle of incidence regarding with in respect of the normal. We measure the angle between the angle of ray, the ray what we are projecting on the surface, and the normal. But in geography it is not like that. There is a little bit difference. We have to measure the angle of incidence from the ray and from the earth surface. It is not related with normal. It is associated with earth surface and the beam of incidence. So this is the major difference what we have to remember for question solving. This can be the trap in the options. So now let's discuss the angle of incidence. So angle of incidence will be more at equator, then the insolation received at the equator will be more. As we proceed in the higher latitudes, that is temperate region or the polar region, the angle of incidence is decreasing. That's why the solar insolation is also decreasing, and all these things are occurred due to the geoidal shape of earth. So the tilt of the earth is also one of the factor which affects the solar insolation. Like in the June month, 21st of June, the solar insolation is maximum at the Tropic of Cancer, while in December the solar insolation is maximum at the Tropic of Capricorn. It means the tilt of earth is also responsible for change in season. So this is the first part which affects the solar insolation, and it is not only occur in the season. The solar insolation also different. It is changing continuously during the day to night also. For example, it is continuously changing from sunset to sunrise or sunrise to sunset. Now the second part is the duration of the day. If the duration of the day is more, then the solar insolation will be more, the heating of the earth will be more. But another factor also depends on it. In the higher latitude, the daytime is more, but the temperature of the earth is less. It is due to the first factor what we have discussed, the angle of incidence, because the angle of incidence is more at the equator, and it is decreasing in the temperate region or the higher latitude, then the insolation is less there. That's why the upper latitudes are possessing less heat, or the surface of the earth is less there, and the heating is more occurring in the equatorial region. Now the third part is the elliptical shape of earth. Due to the elliptical shape of earth, when the earth is near to the sun, then the solar insolation is more, and again the heating will be more. And when the sun is farthest from the earth, then the solar insolation will be less, and due to which the heating of the earth will be also less. And this variation can be traced up to plus minus 3%. So it is a great difference which affected by the elliptical orbit of the earth. In the extreme cases, it is the northern hemisphere which is always on the positive side, which is on the beneficial side or advantageous side, and the southern hemisphere is at the costlier side, means the southern hemisphere have to bear the cost. Since the northern hemisphere is mostly comprised of continent, and the southern here is mostly comprised of oceanic basin, so the temperature variation is less significant in southern hemisphere, and it is of the moderation side. Now our fourth point is atmospheric processes and cloud cover. Yes, the significant amount of solar insolation is affected by the cloud cover and the atmospheric processes. During the rainy season, the cloud cover is more, so they restrict the solar insolation, and the less amount of insolation is reached to the earth, because most of the part are reflected from the cloud itself. So it was due to scattering, reflection and absorption also. Some of the amounts are absorbed and some of the amounts are reflected and partly are scattered, and this in turn cools the earth's surface. And the fifth part is aspect of albedo slope. So if the solar insolation is occurred on one part of the mountainous terrain, so on the leeward side the heat will be less, and on the direct side where the heat is, the solar insolation is directly occurred, there the heat will be more. So this is also the things which can be considered, but these are the factors which not significantly affect. The significantly affecting factors are the angle of incidence. And the sixth part, if we will discuss, then it is the sunspot cycle, which is responsible only 0.1% in solar insolation and its change, but yes, it can be discussed in factors affecting the solar insolation. So sunspot cycles are the magnetic anomalies on the sun's surface. It is occur in the cycle period of 11 years. For example, the magnetic polarity from the north to south direction is for 11 years, and it will be turned from south to north in the next 11 years. So this whole cycle is completing in 22 years, and the half cycle is, that is reversal of the polarity, is in 11 years, and the complete cycle is for 22 years, not 12 years. It is for 22 years. And due to the sunspot cycle, the solar flares are occurred on from the surface of sun to the earth, which also affect the communication satellites, and polar lights are also occurred due to them. That is, the in the northern hemisphere it is aurora borealis, and in the southern hemisphere it is aurora australis. And if we talk about on the surface of the sun, when there is solar maxima, the sunspots are relatively at low temperature.